Problem number 11, you want to find equations for each horizontal tangent line of this function. Horizontal tangent line means that we're looking for places where the derivative of this function is equal to 0. So how do we attack this? We take the derivative, we set it equal to 0, we solve. We've got a quotient, so we want to use the quotient rule here to calculate the derivative. F prime of x is equal to, I always write the denominator squared first. Upstairs, it's the low function times the derivative of the top function, derivative of the numerator. Derivative of 8e to the x is just 8e to the x, minus the top function, 8e to the x, times the derivative of the downstairs. Derivative of x minus 3 is 1. Okay. Let's see, does anything simplify here? Does anything factor? It looks like that we can factor out a factor of 8e to the x times everything else up here. So x minus 3 minus 1 would be x minus 4. All of that over x minus 3 squared. Okay. Let's remember, what are we trying to do? We want this to equal 0. 8e to the x, so that's never going to equal 0. X minus 3, that might equal 0, but that would just make the derivative undefined. In fact, the function itself just would be undefined when x is equal to 3. So the only thing we have to worry about is at the point when x is equal to 4. This is the only point at which we have a horizontal tangent line. Okay, so we know that we have a horizontal tangent line at x equal to 4. Horizontal tangent line, it would look something like this here. Horizontal tangent line means that we're looking for something of the form y is equal to a constant. So the very last thing we have to do in this problem is to substitute in 4. Determine what f of 4 is here. F of 4 is 8e to the 4th divided by 4 minus 3. It's just 8e to the 4th. So the equation of our horizontal tangent line is going to be y is equal to 8e to the 4th. So yeah, I guess the calculated derivatives here is relatively straightforward. The trickiness, the hard part is just realizing horizontal tangent line means you're being asked to figure out when is the derivative equal to 0 and make sure you come up with the correct object that you're being asked for. Okay, problem number 12 here. Take a look at this limit. This is the limit definition of the derivative for some function at some point. Our job is to identify this. How do we do this? We want to use one of the versions of the definition of the derivative. And the version that we're going to be using is the limit as x goes to a of f of x minus f of a over x minus a. This is equal to f prime of a. Okay, so this is one of the definitions of the limit definition of the derivative that you should know. And so once that we take a look at this, we can try to start making comparisons, identify things with each other. So for example, the fact that we have this x minus pi over 8 downstairs, that sure looks like that we're going to have a is equal to pi over 8. And that also is reinforced by limit as x goes to pi over 8, limit as x goes to a. Yeah, we're identifying a with pi over 8. Upstairs, tangent of 2x, this should be f of x and let's just check that by what's the check that we should be doing. This 1 value here, this should be f of a. And so let's check that. F of A is tangent of 2 times pi over 8. Using this as our f of x and this is our a. So this is tangent of pi over 4, and yes, this is one of the, this is a very good trigonometric function value to know here. Tangent of pi over 4 is 1. So yes, everything checks out here. This is the limit definition of the derivative for the function tangent of 2x, written at the point a is equal to pi over 8. Okay, so how do we do part B now? Use our identifications in part A to calculate a given limit. Well, let's not try to evaluate. This would be a somewhat difficult limit to evaluate from scratch. So instead, let's just use the fact that, well, we know that f of x is tangent of 2x. So f prime of x is going to be 2 secant squared of 2x. Let me square that. Okay, so this is, we're using chain rule and rule for the derivative of tangent of 2x here to come up with what is f prime of x here. So f prime of a, f prime of pi over 8, will be 2 times secant of 2 times pi over 8 squared. And so now we just have to evaluate this. 2 times secant of pi over 4 squared. Secant of pi over 4 is 1 over cosine of pi over 4. And cosine of pi over 4 is 1 over root 2. So secant of pi over 4 is root 2. 2 times root 2 squared is 4. Okay, that's problem number 12. Yeah, I think it's a good place to wrap this video.